Hey, what's going on, guys? Let's do this problem right here. Here this question is asking, suppose 2 joules of work is needed to stretch a spring from its natural length of 30 centimeter to a length of 42 centimeter, right? How much work is required to stretch it from 35 centimeter to 40 centimeter? Now, whenever we do these kind of problems, we have to always take the other lengths from the natural length, because we take natural length as 0. So this distance is going to be 5 centimeter, right? From natural length 30 centimeter, this is going to be 5 centimeter, this is going to be 10 centimeter. So this is what they are asking to find. How much work is required to stretch it from 35 centimeter to 40 centimeter. Now here we are going to use Hooke's law. In Hooke's law, f of x is going to be kx, right? Now to find the work, we use this equation, that is work is equivalent to integral a to b f of x dx. So in spring system we use Hooke's law, that's going to be a to b kx dx. Now let's go ahead and see what we have. Here we have the length, that's going to be the limits of integration. So if we put the length, we have to use the SI unit. This is in centimeter, so if we convert this one into meter, we have to always use the distance from natural length, that is 5 centimeter. So if we convert this one into meter, that's going to give us 0.05, right? And in the top integration, we are going to have 0.1 meter. So this is going to be the limits of integration, kx dx. But here, in order to find this work, we have to have k, that's spring constant, but it's not provided in the question, right? That's why we have to use the previous information to calculate k. Previously they have mentioned, suppose 2 joules of work is needed to stretch a spring from natural length of 30 centimeter to length of 42 centimeter. So they have given the work already, and also we have the distance. So we can use this information to find the k. Now let's go ahead and find k. W is equal to, again same equation, W is equal to integration. So we always take natural length as 0. So 0 from 30, natural length is 30, 30 to this distance is going to be 12 centimeter, right? So 0 to 12 centimeter. So that's going to be 12 centimeter. If you convert this one into SI unit, that's meter, that's going to give us 0.12 meter. Right? So this is our equation, and kx dx. Let's plug the values. Work is given, that's 2 joule. 2 is equivalent to 0 to 0.212 kx dx. And if we integrate this one, this is going to give us kx square divided by 2, going from 0 to 0.12. Now let's apply the integration, limits of integration. Here we are going to have 2 is equal to k 0.12 square over 2 minus, and if you apply 0, everything is going to be 0, so we can just put 0 right here. It's not going to change anything. Now here this is going to be k is equal to 4 over 0.12 square, and if you calculate this one, you should get 277.78. This is going to be Newton per meter, right? So this is going to be Newton per meter, because we are dividing joules per meter square, so that's going to be Newton per meter, yeah. So we get Newton per meter, and now we have the k value. Now we can go ahead and find this work done in the second information, right? Now let's get rid of this part. We only need this spring constant. After we find this is unnecessary, right? So we can get rid of this one. Now let's continue this one right here. So here we have the spring constant that's provided. So work is going to be equivalent to integration. We found out the limits of integration already, that is 0.05 to 0.1. K is found, that's 277.78 x dx. And if you integrate this one, that's going to give you 277.78 x squared divided by 2. And that's going from 0.05 to 0.1. Now let's apply this integration. This is going to become 277.78 times 0.1 square over 2 minus 277.78 0.05 square divided by 2. And if you apply everything and calculate this value, you should get 1.04 joule. And that's going to be the work is required to stretch this one from 35 centimeter to 40 centimeter. I hope this helps. Thanks for watching.